Hi you guys, welcome back to another video. It's Jag if you're new here. If not, welcome back. This channel is focusing on basically math, science, and English at the high school level. It's going to be from grades 9 to 12. And we're going to try to revive this channel. However, if you want to take a look at a lot of the old videos from the past years, you're welcome to do so. We're basically going to be focusing this semester on grade 11 math. This is the math at the university level, grade 12 calculus and vectors, as well as grade 12 advanced functions. Because these courses are just so important for university, I think students would find it very helpful. I actually teach at a private school, grades 9 to 12. I also teach science, grades 9, 10, biology, chemistry, and physics at the grade 11, 12 level. So we'll definitely try to do a few lectures on particular concepts. As we're going through a lot of the concepts right now, definitely will be a review, and there have been past videos on these concepts already, but I'm going to put everything into a playlist, and that way it's very easy for you to kind of access all the videos together for each grade level and each course. So I think you'd find that very helpful. All right, so with that, let's get started. All right, so today's lesson is Math 11, inverse of a function. And I'm actually teaching Math 11 University right now, Calculus and Vectors grade 12. And so I noticed there were some mistakes on the unit test, as basically we already had the unit test for this section. So we're going to go through some examples here. You'll definitely find it very helpful. Let's try example 1. It says determine the inverse numerically. This table here is showing the f of x function for these ordered pairs, and you're basically determining the inverse function, right? And then you can state the domain and range for both f of x and its inverse. So I basically already wrote it down here. Like you can see, when the teacher gives you these coordinates for the f of x function, like -5 and 0, for the inverse function, you're just going to reverse the coordinates. So it's 0 and -5. The next coordinate is -4 and 2, and you're going to reverse that to 2 and -4. Then the next coordinate is -3 and 5. It becomes 5 and -3. And then -2 and 6 becomes 6 and -2. And the last coordinate is 0 and 7. And then when you reverse that, it's going to be 7 and 0. Okay, so I think let's actually graph this out actually. So I'm going to add some more points here to the Cartesian plane. So first point is -5 and 0. So you're going to make a dot right there. Right? And then -4 and 2. So -4 and 2. So remember again, so this is just going to be like a sketch here, right? But remember, because these are individual points right here and coordinates, so you're not going to join these dots together, okay? And the next coordinate is -3 and 5, right, which is up here. And then -2, I'm just going to add a 6. So -2 and 6. And of course, if you have graph paper, make sure you are always doing all the questions on graph paper. And the last point is actually 0 and 7. Okay, so it looks like this. So you can see right here, the first for your ordered pairs, okay, the first number is representing the x-coordinate. The second one is the y-coordinate, right? So it looks like this. And also, the inverse function is always going to be a reflection, okay? It's going to be a reflection in this line. And this is basically the y equals x, okay, line. So now let's go to, so these are the points for the f of x function. So now we're going to do the inverse function. So it's 0 and -5, right, which is right here. And then 2, -4. So 2, -4. 5 and -3. 6 and -2. All right, so we're right here, 6, -2. And the last coordinate is 7 and 0, which again is going to be right here, right, on the x-axis. So you don't need to actually write the coordinates here, okay? Because we already have the coordinates in the table. But if you look at these dots, right, we can see, let's make that bigger. We can see that these dots are basically a reflection in the y equals x line, like so. Okay, so hopefully everyone sees that. So if you're given individual coordinates, you're basically just going to reverse the x and y coordinates. And when you plot it out, you'll see that it is indeed a reflection, okay, in the y equals x axis or like line. However, let's also do, say for f of x, right? Let's write the domain. I'm just going to put D up here. And you're going to make like your squiggly bracket. Oh, actually, we're not going to put x's on your numbers because I have exact points here and coordinates. So let me take that out. Right? I'm going to put -5, -4. And you're basically just like stating, okay, all of the coordinates right here. And then for the range as well, I'm going to put 0, 2, 5, 6, 7, like this. Right? And then you're going to do the inverse function like f -1x. And remember, when you're stating again the domain and the range, it has to be in order from least to greatest. Okay, so let's do f -1x here, the domain. Okay, the domain represents these x values, so I just have to make sure they are in order, which they are, right? Same thing with the range, -5, and then it's going to 0. -4, -3, -2, and 0, and like this. So the only time you state the domain and range like this separately as the numbers is if you're actually given these individual coordinates. All right, and that's it for example 1. It says, notice that the domain of f of x is the range of the f of -1x, and the range of f of x is the domain of f of -1x. Right? And so basically here, systematic method for determining the inverse of a function algebraically, because we're going to do that for example 2 now. Write the equation in the y equals form, which is kind of like the slope-intercept form. If it is not already in that form, step 2 is going to be interchange x and y in the equation. Step 3, solve the new equation for y. And step 4 is replace y with f -1x. All right, so with that, let's move on to example 2. All right, so let's go to example 2 here. It says determine the inverse algebraically. So first we're going to try like a really simple question. It says f of x equals 2x minus 3. So instead of f of x, I'm going to write y equals 2x minus 3. Right? And we just went through like the steps already. So step 2 is going to be interchange x and y in the equation. So now we're going to write x equals 2y minus 3. Does everyone see that? We're just switching x and y here. And then what you're doing in step 3, solve the new equation for y. So we're basically going to isolate for y now. I'm going to take the -3 to the other side. Becomes +3. So x plus 3 equals 2y. Then I'm going to divide by 2 on both sides. All right, and the 2 is going to cancel out like we see here. Okay, so basically y is equal to this whole expression, but we want to just make sure we're changing the y back like this to f -1x equals x plus 3 over 2. So don't leave your final answer in terms of y here. This is the proper notation for the inverse function. And again, of course, it doesn't tell you to graph it out here. But if the teacher told you to graph this out, because there have been questions in the past, what you could do is basically just make an x and y table, right, for this function itself. So let's do it here so you can see, right? Let's say a couple of values, okay? So let's do like, say, if x is -1, this would be -1 times 2. So -2 minus 3, so -5. If I want to put 0, 2 times 0 is 0 minus 3, like this. And then if x is equal to 1, I'm going to sub in 1 here. So 2 times 1 is 2 minus 3, which is negative 1. All right, and you can already see that there's like a pattern here, right? And I know there has to be a pattern for the y-coordinates here. This is like a linear function, right? And I know it's a straight line already. Right, and then if you want to do the inverse function coordinates, I mean, this looks like a really simple function. I can sub in values for x here as well. I don't need to do that. I can just reverse these coordinates. So I'm going to put negative 5, negative 1, 0, negative 3. So we'll put negative 3 and 0. And this is 1 and negative 1. So I'm going to put negative 1 and 1. Does everyone see that? Right, so it's easier for you to actually make a table like so. I'm going to join the table together, right? Like this. You can do a few coordinates, and I don't need to do like 5, 6 coordinates. 3 coordinates is like really enough because I know this is already a linear function. It's a straight line. And for the inverse function, you're just going to reverse these coordinates that you see like right here. And now you have 3 coordinates for basically the inverse function as well. Right? And this is actually a simple function. Like I said, I can also substitute some values for x here to get some coordinates for the inverse function. But as you'll see in question B, the actual function can be a little bit more complex. So it's easier if you want to graph it, that you just make like a quick table like this, pick a few coordinates on f of x, the function, and then to the inverse function, just reverse the x and y coordinates, like so. Right, and you can also check these coordinates here as well. If I plug in negative 3, this is negative 3 plus 3, 0 divided by 2, which is 0. If you sub in negative 1, this is negative 1 plus 2, which is 2 divided by 2, which is equal to 1. So you can always be checking all of your coordinates as you're doing each step, as you're solving the question. All right, so with that, let's move to part B. And we're going to try, maybe I'll just write it right here. B says f of x equals like 2x squared plus 16x plus 29. So again, we're not going to graph this out because the question just says to solve it algebraically. However, as soon as I see like an x squared like this, I know that this is a quadratic function. And when you're finding actually the inverse of the quadratic function, what I want to do is complete the square. If I see something in front of the x squared here, I want to make sure I factor this out. So I'm putting brackets around the first 2 terms here. We're going to factor out the 2, and I'm left with x squared plus 16 divided by 2, which is 8x, close the bracket, plus 29. Okay, does everyone see that? So the x squared has to be by itself, okay? So now, if I want to do my perfect square, you're going to take this number that's in front of the x, which is 8. Don't worry about the sign. You're going to divide it by 2. And the perfect square is equal to 4. Okay? So now you're going to, in the next step, add and subtract the perfect square. So I'm going to do x squared plus 8x plus 4 squared minus 4 squared plus 29. You see that? Of course, you can skip some steps. I'm not going to skip it right now. And x squared plus 8x, like plus 16 minus 16 plus 29. And whatever this negative perfect square is, you're going to take it outside. However, when you take it outside, make sure you're doing negative 16 times 2. Right? So let's write one step here. Right? So negative 16 times 2, so negative 32 plus 29. Okay, so this, if you get confused, maybe just write out each of these steps as you're going down, okay? Because the signs here are really important. And now, basically what you are doing is just factoring this out, but this is basically a perfect square trinomial. The perfect square is 4. So I'm going to put x plus 4 whole squared. And you're going to do negative 32 plus 29, which is negative 3, like this. And this is your f of x function, like we see right here, okay? And why did we do this? Because we're looking for the inverse function. So even if you're doing application questions, it's basically the same thing. So now we're going to put y equals 2x plus 4 whole squared minus 3. And also, how do you know that this sign here is positive? Whatever the sign is between the first two terms, that's the sign you'll see inside the bracket. So if this was negative, the sign inside the brackets would also be negative, right? And the second step is we're going to switch the x and y. So I'm going to put x equals 2 y plus 4 squared minus 3. All right, you're going to take this negative 3 to the other side. So now we're solving for the inverse. So it becomes x plus 3 equals 2 y plus 4 squared. Right, I'm going to divide it by 2 on both sides. So the 2 cancels out like this. Right, to get rid of the squared, you have to take the square root on both sides. Okay, and then we'll write it on this side right here. Remember, when you take the square root, right, so it says x plus 3, 2 equals, and we're actually left with y plus 4. But every time you take the square root, you have to make sure you're putting plus or minus, okay, like so. Right, and when I took the square root on both sides here, it basically gets rid of the squared sign. That's why we're left with y plus 4. I'm going to take the positive 4 to the other side. Okay, and you can see it just becomes like negative 4. So I'm going to put f negative 1x equals negative 4, right, plus or minus square root x plus 3 over 2. Right, like this. It doesn't matter if you put the negative 4 in the front or behind, okay? But the important thing is that you have the plus or minus sign in front of the square root, right? And that basically just comes from like the quadratic formula, right? So this is my final answer, okay? And again, make sure you're using this proper notation, f negative 1x, that represents the inverse function. And also, if you just to quickly take a look at this function, do you see how like complex this function is? Because this is actually the inverse of like this quadratic function right here. Oh, actually, we don't even know if this is a function. You have to actually graph it out, because sometimes the inverse function is basically like a sideways parabola. It does not pass the vertical line test, and it's usually not a function, okay? But this is very complex. So you see like how we made like a table up here. I would make the table for the f of x function for the quadratic if I had to graph it out. And then you can easily just switch the x and y coordinates, right, to get the coordinates for the inverse function if you need to graph it. Okay, because that was definitely, I think, one of the questions that students had as well on the test. And that's the fastest way for you to graph the inverse function. And even if the numbers are really big, especially for the y coordinates, you can always just take a scale along the y-axis to graph it out. All right, and that's about it. Those are the two main examples I wanted to go through. All right, so that brings this video to a conclusion. And I really wanted to go through those two examples step by step, so you know how to actually do the questions and find the inverse of a function. Again, if you have any questions, make sure you're putting that in the chat below, and I'll get back to you right away. So thank you for watching. Please make sure you like, share, and subscribe to this channel, and I'll see everyone next time. Bye.